Now let's look at wires and wiring, or conductors. A conductor, basically a wire or a cable, is a material that allows current to flow. And the kinds of materials that allow current to flow have valence shells, those outer shells of electron orbits, that are not full. If you have a shell with only one electron in it, like copper has, it's easy to knock that electron loose. So that material, like copper, conducts current easily. All conductors have 1, 2, or 3 electrons in their outer shells. There are a few materials called semiconductors that have 4 valence electrons. The best conductors are listed here. Gold is actually the best conductor, but it's expensive, so we don't use it, and it's soft, by the way, so we don't use it in wiring. Silver is also top and expensive. We use copper and aluminum, the next best conductors. An insulator is a material that does not allow current to flow, and most insulators are not elements, as copper and aluminum are. Most insulators are compounds of elements, so rubber, plastic, and so forth. The National Electrical Code writes rules about wires, about conductors, and it says these wires must be copper or aluminum, and they must be insulated. The National Electrical Code, revised every few years, is adopted by states, and so it is the law. It becomes the law in every state and county and city where it is adopted. And its purpose is mostly to prevent fire, but also to prevent electrocution. And it specifies what sizes you shall use for wires, what kinds of insulation around the wires, what kind of breakers you have to put in the circuits, and so forth. The size of your wires is measured in a system called AWG, American Wire Gauge. And you might want to pick up one of these sheet metal gauges, wire gauges, for yourself if you have a few extra bucks and want to buy yourself a present. They're kind of handy to have. And what you do is you slip the slot over a wire, and if it just goes over the wire, that's the wire size. Anyway, there are several different systems of measuring sheet metal and wire, and so the one we use is AWG. A big number means a small wire size, so 40 gauge is a small wire. A small number, like 1 or 0 or even 4 zeros, which is called 4/0, a small number means a big wire. So small number, big wire, big number, small wire. When we're thinking about the electrical code and preventing fire, we need to know that if a wire is too small, it will overheat. That's what causes a wire to overheat. It's if it is too small for the current it's trying to carry. So the electrical code is very specific about what size of wire you have to use, depending on how many amps are flowing through your circuit. A big wire can carry more current, and that's because of resistance. A small wire heats up if it carries too much current. That's because of resistance. Next time we'll look more at circuits in a house. So a house has all this electrical equipment, and it's plugged into circuits, and a circuit is a closed loop. So we have a power source somewhere. It might be a battery in a flashlight. It might be a receptacle in the wall that's bringing power from the power plant, but there's a source. the current flows through the conductors out to the load, which might be a light bulb, and then in a closed loop path flows back again. So every circuit has to make a closed loop or current won't flow. And most circuits have these parts, and we'll look at these next time. There's the power source from the wall. There are the conductors and their insulation that carries the current through the wall. There's the load, and that means the light bulb or the stove or the computer. There's something for controlling the current. That might be a switch. And then there's always some kind of protection, and that might be a fuse or a circuit breaker. So that makes, oh, and then just to repeat, that has to make a closed loop back to the source. So that's what makes a circuit.